But yeah, so welcome. So I'm going to be kicking off tonight, kind of setting the scene, I guess, for the two other awesome speakers we got as well. This is a longer talk, so I've kind of hacked it down a little bit. Hopefully it makes sense. If there's anything you'd like to know more as we go along, I'll be around all night tonight, and you always ping me on Twitter at Daniel Bryant, or email or stuff I'll share at the end as well. But the kind of core pitch is I've been working with containers now, pre-Docker stuff pretty much. And as with many new technologies, it looks awesome at first glance. When you start using it, there's often a few problems, yeah? It sounds so simple. We take our monoliths, we take our microservices, we package it in these nice shiny boxes, ship it, kind of good to go, yeah? Everyone makes sense? We've been sold and that kind of thing. The only snag is, if you've got a bit of a tire-fire architecture, or tire-fire app, and let's be honest, who hasn't got a few of them, alone in an enterprise, and you try to put that in a container, what you actually end up with is tire-fire in a container, yeah? And you'll see the firefighters down there. This is what we call as DevOps in the modern world. This is how I make my money as a consultant, yeah? But all jokes aside, as in, it's not as simple as it might first seem. Docker, container technology, super powerful, but with great power comes great responsibility, pretty much, yeah? That's my pitch for tonight. Continuous delivery is a large topic. I'm actually writing a book for my sins, and I'm realizing how large that topic is now. I've got a free teaser of the book available, thanks to Nginx, so you can pop along to the bit.ly link and get that one. Tonight, we're going to be looking purely at the tech, no business focus. I love my business stuff. I love my value stream, that kind of thing. I also think, for example, on the technology side, PaaS and serverless are super interesting. But this talk is making the assumption you're all in on containers. So you can chat to me afterwards if you want to know about Cloud Foundry, Lambda. I think they're super interesting, and context is massively important in how you make your decisions of whatever technology you choose to build and deploy on. We're going to be focusing on the process and tooling quite high level, hopefully a good intro for the guys. No live coding because I'm rubbish at it, and the mini book contains more of the kind of details that you can, and code examples. There's a GitHub repo and all that kind of good stuff as well. So the takeaways, I'd like you to kind of, this is what I'm going to prime you a little bit. I'd like you to be looking at the talk going along the next 20, 30 minutes and realize that when we're building containers, the container image should be the single binary going down a build pipeline. Yeah? When I say single binary, I mean what I see sometimes is people building an artifact, a platform-specific artifact, and only packaging it in a container right down the end, the pipeline, or repackaging it in containers several times along the pipeline. Following Jez Humble and Dave Farley's lead, the single binary is the one sort of single piece flow that should be going down your pipeline, and that for me now is the container image, a single container image. Okay? Adding metadata to anything is super, super important. In terms of governance, in terms of software supply chain, that's a whole talk in itself. But I believe metadata is really valuable. I've struggled sometimes adding metadata to containers, I'll be honest. Got a few hints there as well. Containers, as with anything in this kind of space, can often change the deployment fabric. Yeah, they kind of alter the properties. So I remember when I first moved to cloud, 10 years ago now, I guess, moving to cloud, realizing everything was networked, made a big impact on the code I wrote. Yeah, I got burned a few times. Same with containers. Containers do alter the fabric you're deploying onto. There's a few Java-specific examples, because I am mainly a Java developer these days, but the principles apply to whatever language, and there's a few gotchas to watch out for that me and my team and I should say, have made, and I'd like to share with you, so hopefully you don't make the same mistakes. Does that sound like a fair deal? Is everyone happy with that? It sounds like a plan. Sweet. So this is me at Daniel Bryant UK, love getting involved in that. Independent tech consultant, CTO for a spin-out of Open Credo called Specto Labs, who specialize in microservice testing frameworks, open source tools, and workshops and stuff, so hit me up afterwards. But big thing here tonight, loving the continuous delivery. Really see the value of it, right from my Java EE days, through to cloud, through to containers, super, super powerful, both for driving change in teams and technology. I truly believe continuous delivery is a catalyst for many good things. Yeah, many good things. So actually, this slide is almost redundant. You're at the CD meetup. I'm assuming everyone is totally cool. We worship at the altar of Jez and Dave. Yeah, we're all cool with that. Yeah, awesome book, seriously worth a read. It's all about feedback, learning, and continuous delivery, operating in short cycles, not necessarily continuous deployment. Some of the enterprises I work at, when you mention about continuous deployment, they get a bit scared. So continuous delivery, you can deploy it, but you can have a human in the mix if you want as well. You don't have to go right from my dev laptop through to production without any interference. That's the dream, that's the goal, but you don't have to, yeah, with continuous delivery. Again, hopefully not controversial for this audience, creation of a build pipeline, mandatory for continuous delivery. Yeah, and again, I think I'm preaching to the choir, but this is a sort of typical Java flavored pipeline, I think, but it's a very standard pipeline, coding on my local machine, push up to DVCS like GitHub, Jenkins or Circle CI or take your pick, TeamCity, doing some builds, doing some code quality analysis, put my artifact into a repo, put it down for QA, do some testing on QA. If we're good, staging. Staging is probably more like live, more realistic. Maybe I'm mocking things in QA, but running sandboxes of third-party systems in staging. And I push through to prod. Now, and I've not done this justice on this diagram, but the key thing is continuous delivery does not end when my service or my code is in production. Yeah? Continuous delivery ends when my service has been retired. Yeah, when my code is no longer there, pretty much. Yeah, you want to add observability on, and I'm not going to talk about that lots tonight because it's a big topic, to be honest. But you need observability from an architectural quality point of view, from an operational point of view, and definitely from a business point of view. You want to complete basically the feedback loop. Yeah, the ideal goal is hypothesis-driven development here. We come up with some ideas, come up with a hypothesis, we put some metrics in, we bake it down through, and then we basically do our experiment in production, and we feed it all back. So don't forget that loop. It's something I must update this diagram. It is it's a pipeline, but there's always a loop in terms of the feedback from all different angles. Business, architecture, and ops. I'm assuming everyone's pretty comfortable with container tech here. General sort of nods. For me, it's kind of Goldilocks virtualization, hardware virtualization, app virtualization like the JVM, the CLR. OS level virtualization is the Goldilocks zone, the kind of in the middle of the virtualizations. Control groups for controlling resources, namespaces for processes, networking, and a rootfs. So when you trash the container, you're not trashing your root file system. Docker, did a fantastic job building on LXC and then taking it even further than that. They did a fantastic job with developer UX, developer experience. Yeah, great API, the Docker Hub, all this kind of good stuff. They've done in an industry the great sort of service of bringing containers to the mainstream. And of course, there's Microsoft, which I'm sure Marcus will talk about more later, Hyper-V, and there's LXC, LXD, Rocket, a whole bunch of different container techs. I, to be honest, have mostly used Docker. That's just because of the clients I work with, and I'm mostly familiar with Docker. So where you see Docker on the slides tonight, substitute it for any kind of container tech. It's all good, as far as I'm concerned. Excuse me one second. So we've got our pipeline here. How does it change with the introduction of container tech? Yeah, not vastly, to be honest, but there's 4 key points I pull out in the little mini book. One is developing on my local machine. Probably want to spin some stuff up with containers now because I want to make my development environment as live as possible. And now I'm probably not only deploying to say an artifact repository, I'm probably now going to be deploying to an image repository because I've got my container as the single binary. Changes there. The way I spin up things for testing might be a little bit different now because I'm ultimately deploying onto a different fabric, most likely Amazon ECS, Kubernetes, Mesos, all that kind of good stuff. Because if you're running more than a few containers, systemd pretty much doesn't cut it. You can get away with kind of spinning up things on just a Linux box, but things like Kubernetes, very useful. I found done quite a bit of work with Kubernetes for running, for orchestrating, for scheduling your container workloads in production. Yeah. So does that make sense to everyone? Kind of the flow, containers making a little bit of an impact in a few different places there. Let's dive into it in a bit more, bit more depth, starting at dev. So I do a lot of Java stuff. I, to be honest, mostly code in IntelliJ, like my IDE, and I'll often then put stuff in a container as part of the build on my local machine and run my happy path tests on the containerized version of the Java archive, the Java build artifact. Yeah, I don't think you can get away with just coding locally and say pushing stuff to the pipeline and then containerizing it. I think really you need Docker or whatever on your machine. You're building that mechanical sympathy. Yeah, you're working with Docker, you're seeing things around the control groups, the namespaces, all these kind of good things. A little bit of an aside, many people looking at container tech are working with microservice systems. Yeah, so if you are working, I saw this very interesting Hacker News article that said, what was it? It said something like, you're not doing microservices unless you can spin up your whole system on your laptop. Not doing microservices unless you can spin up your whole system. And I was like, they've never worked with a system of any scale or any legacy or money-making software, basically, yeah? Any kind of vintage, whatever you want to call it, as in, because I can't spin up mainframe stuff that easily on my laptop. So I bumped into this a couple of years ago when I was working at Open Credo, blogged about it, come up with some patterns that we sort of worked with, my team and I, and we sort of stood on the shoulders of giants there as well. And there's been a few tools, a few open source tools that have been created to address some of the challenges of working with a bigger system. So I'm developing locally my application, my service, but it might be part of a bigger system. Got to shout out DataWire, awesome tool called Telepresence that allows me to run a big sort of, say it's Kubernetes specific at the moment. I run a Kubernetes cluster, maybe it's a cluster on demand, I spin up in Amazon, I spin up on Tectonic, whatever, and Telepresence proxies my local machine into the cluster. So I can develop locally and debug using all my tools locally, but it's as if I'm working in the cluster. That service can talk to other pods. I can look at the persistent claims and the volumes, all these kind of things. And I can look at the environment variables. I can use all the tooling I've got on my machine as if I was in the cluster. So I can dig namespaces, all that kind of good, dig DNS and all that kind of good stuff. Shameless plug to one of the companies I work with at the moment, Specto Labs. We're seeing a lot of people now using things like service virtualization. So it doesn't have to be Hoverfly, and there's lots of other open source tools. This is open source, Go-based open source service virtualization. There's Mountebank, Wiremock, a bunch of other good things. But they basically allow you to synthesize external systems. You can do record, replay, you can build effectively mocks, and you can run them, and they allow you to simulate the network stack. So it's kind of mocks plus. Yeah, you can do your fault tolerance testing, do fault injection. You can run many, for example, hoverflies, many wiremocks, many Mountebanks, because the resource footprint of these things is much lighter than external services. Hoverfly does HTTP and HTTPS. Mountebank does TCP as well, so that's quite a nice kind of alternative. Slight aside, but getting started locally is often a big challenge in my experience. And setting yourself up right developing locally, particularly if you're doing microservices or some kind of service, these tools I found very helpful. But links down there for you to find, all open source tools as well. But back to the action. One caveat I will mention is use identical base images from production in your local tests. I saw some people using Ubuntu locally because they were most comfortable with Ubuntu, and they were deploying into CentOS in production. And there were subtle and not so subtle bugs with doing that, to be honest. Excuse me. Lessons learned, hopefully if you've played with Docker, you probably get this, but Dockerfile content, Dockerfile is pretty much your manifest saying what image you're building from, what OS you're using, how you're adding your binary or your artifact, what kind of ports you're exposing, other configuration to get the app started. Excuse me. This stuff is really important, and many developers are not as operationally aware as perhaps we are. I think we're probably a self-selecting audience. We're come to meetups, we're interested in CD and containers, and we may be quite comfortable at the Linux terminal, comfortable with LXC, comfortable with C groups. Many people I work with are not, and therefore they need guidance on these kind of things. And when we are kind of technical leaders here, yeah, we're coming to the meetups, so we should try and educate everyone else, try and feed these things back. I think it's a really important part of my job. Part of the reason I do these kind of talks is to kind of help everyone else and share the knowledge I've got, and make the point is that it's about empathy. Not everyone is thinking alike, not everyone's skills are the same, but we can hopefully help them is the pitch. Yeah. I'll leave you, if you can have a chat about these things later. I've done a fair bit of Java, Golang and Python, and they threw up a few interesting things within a container, but might skip that tonight for the time. This is one of my favorite slides. Please talk to the sysadmin people because their operational knowledge is invaluable. Yeah. Even developers need heroes, yeah. This, I think, is really important. I have seen teams where they didn't talk to InfoSec until the last minute, they didn't talk to Ops until the last minute, and whole projects have been threatened. So now, as a consultant, I roll in. One of my first questions often is, let's get InfoSec in the room. Let's get Ops in the room. Their knowledge is super useful, and getting buy-in from day one saves me a bunch of time later on, So this stuff is, hopefully preaching to the choir, but many people, Docker has been really powerful for developers. It's enabled us to go so much faster, but it's also allowed us to experiment with things that we're perhaps not used to as well. Double-edged sword. Moving on, so I'm going to kind of skip in building images. I use Jenkins quite a lot. The report goes into that. I've got a GitHub repo you can check out. I often use CloudBees, Docker build and publish plugin in Jenkins. Push the image to a registry. Docker Hub, I'll mention a bunch of other ones later on, but fundamentally you package your thing. If it's Java, it's a Java archive. If it's Ruby, it might be a gem, or it might be the code. Python, it tends to be a the code, those kind of things. Whatever, you package that and you put it in the image, and now the image is your single binary that we're going to do our tests on. Around metadata, so I think metadata is really valuable. Knowing where, when things were built, what Git char, because microservices and all the other sort of application architectures, a lot of it's about independent deployment and velocity. So we can go that much faster, but when things go wrong, or even really before when things go wrong, you've got to have some kind of provenance. You've got to know where things are coming from, where they're going to. And Equifax is a rude reminder for the industry. I think it's only going to get worse. I'm not the only one saying that. So these kind of things, bit of provenance, even like quality metadata. Docker and a bunch of other companies are coming up with things where you can sign your images. So you test it, and you sign it, and only signed images can go into production, things like that. Also things like security profiles you can put as metadata, things like SE Linux, AppArmor, SecOmp, all that kind of good stuff. Whether the container has been security audited, we'll look at that in a second. Capturing this data and associating it with your image artifact, super, super important. Yeah. I've often done this kind of stuff through Docker labels. So labels is well spec'd out in the Docker spec online. Basically, it's key value data you can store in the Docker file. There's a nice, microscalings. Microscaling systems are sadly no more. They were an awesome spin out by Anne and Liz. But there's their kind of legacy lives on in GitHub. So they've got some make files to help adding labels like git char and date and all these kind of good things. When you run make basically, and it builds your Docker file with all the up-to-date label data. It's good stuff. There's a few tips there for building on Docker Hub. And if you want to know more about labels, because Docker are being quite casual about the label stuff, Anne, Liz, Michael, a bunch of other interesting people put together labelschema.org and MicroBadger. So more things to perhaps research offline. You can add labels at runtime, so you can say do some testing and try and add a label at runtime, but you can do like I'm running, I think it's Nginx in daemon mode here, putting a label on, but as soon as you stop the container, label goes away. You can Docker commit it. It doesn't get added to the Docker file, but it does get added to the metadata of the container, but it creates a new image, so it kind of violates my single binary thing. Not possible to update running containers yet. It's an open issue on GitHub on Moby now, I guess. Have a look at that if you're interested more in this kind of stuff. Now I think we're seeing solutions pop up that probably don't warrant that previous slide. Liz, for example, Liz Rice works for Aqua. Aqua are a security company specializing in many things but container security, and she's come up with a proof of concept for adding metadata into a Docker registry. So you can run a Docker registry, you can store your blobs, your containers, but you can also store blobs like data blobs. And it is a proof of concept, Liz is very clear about that, but this kind of stuff that I'm finding is really useful. I'm keen to play more with it. It's pretty new stuff, but it's a nice way to get the metadata super close to your container images. Yeah, and I like that. Because the further it drifts apart, the easier it is to kind of lose. I also use registries a lot, so in the Java world, JFrog Artifactory and Nexus, they both support Java artifacts, but also Docker images or container images now. And I can use their proprietary, well, say proprietary, but open source, but I can use their APIs to add metadata to my images and track, security and where things are going. As this is a family-friendly audience, I will point out the frog is purely hugging the whale there. This is straight from the JFrog material, the marketing material. And I looked at it and I was like, it doesn't look right. First time I did this presentation, got a question. What's the frog doing? So I have to state for PG-13, this talk, the frog is purely hugging the whale. Great branding, great. Moving on, swiftly. Moving on. So just some examples to get you thinking. So in the book, I've got a really simple shop, service. I'm not going to say the M word. Really simple shop made of services. Just to kind of give some ideas on how to test these things with Jenkins I was using. If you're just testing one thing, and I appreciate, if you've got a big system, you'd have a gateway on the front, you'd have some databases there as well. But keeping it simple for the moment, I'm a big fan of using Jenkins, as I mentioned already, but Jenkins pipeline as code. So I can create a Docker file in my repo. I can also create a Jenkins file, and I can put Groovy DSL for all my build and all my kind of tests there, which I really like that. I got it in my same repo, Docker file, Jenkins file, good stuff. If you haven't seen the Jenkins end-to-end thing, you can create pipelines of arbitrary complexity. If you're using Circle or a bunch of other CI tools, same kind of deal, to be honest, as well. I like the pattern. I like capturing everything I do as code. I really do like that because I can audit it, I can version it, good stuff. As an example, using the Cloud-Bees plugin, this is some Groovy syntax, Groovy DSL. I can spin up a container. This is a quite crude way of testing, but like setting a timeout for my container to spin up and initialize. This skews the syntax, it's Groovy specific stuff, but essentially I'm just curling, and when I can grep an up on the health endpoint, it returns true, the build passes, we're good to go. Again, don't copy this, but this is a sort of trivialized way of, you can use pipeline as code, you can do a bunch of different things. Some of the newer build tools like Concourse and so forth make some of this stuff, the asynchronous nature of it, a bit nicer. You can also use health checks within Docker images themselves now, Docker containers. Kubernetes has health checks as well, so you can use them probably rather than that pattern, but just some ideas. If you're doing sort of more front end like security testing or load testing, that kind of stuff, I used to use Docker Compose a lot. I use Kubernetes deployment YAML quite a bit, and just chatting before, I see Docker have announced today or yesterday that they're supporting Kubernetes now, which is super interesting. So Kubernetes will be bundled with Docker. So I think Docker Compose is going the way of the dinosaur, to be honest, by the look of it. Kubernetes YAML will be the future. But you can use this kind of thing to specify and spin up some part of your system, or maybe all of your system, and do tests on it. If you're using Jenkins, you can spin up individual build nodes, and you can then kind of treat that as a self-contained system, and you can do load testing on that node and all that kind of good stuff. Just some more examples of how I've sort of scripted doing other things in the past. I'm not going to go through it with the time we got tonight. I'm a big fan of testing non-functional requirements, and I hate the term non-functional requirements because I've seen a few systems that were not functional due to non-functional systems and non-functional requirements, but you get what I mean. I heard of term system quality attributes. I think that's quite nice, system quality attributes. Easier to sell to the business there as well. I'm talking about things like architectural quality, so Java space I use SonarQube, Ruby I use Code Climate, those kind of things. A couple of references for you to sort of read around the quality of software and so forth if you're so interested. Also do things like cyclomatic complexity and other different measures of complexity, particularly if you're migrating away from a monolith. It's interesting to see what's happening in the monolith as well as your new microservices. I've seen a few monoliths kind of degrade into sludge as we've migrated. So by watching these kind of metrics, cyclomatic complexity and cohesion and so forth, good stuff. I always recommend doing performance and load testing in the build pipeline regularly, and with services, I do the tests at the system level and I do the tests at individual service levels. Very simple, happy path tests, but it gives me that kind of trend of how my service is doing. Learned the lesson the hard way 5 years ago working on a service project. We had this system. We didn't realize we were pushing all this code to it, and the performance was gradually going down and down and down, and then it just dropped off a cliff. We pushed it into production, dropped off a cliff, and we had no idea what was going on. We had 10 services in the mix at that time, and so we fixed the issue. From then on in, we used JMeter at the time to put in very simple load testing on each service's happy path, and we tracked it in Jenkins, and we could watch the graph of when we were adding more code, we could see performance going down, and you fix it before it kind of goes completely terminal. So Gatling is my favorite at the moment. Gatling, Scala-based DSL. You don't need to know any Scala, not really. And there's a sister commercial service called Flood.io. So you can write your Gatling scripts, and you can pay Flood.io to run them en masse on EC2. And they can hammer your staging environments with your scripts turned up to the max, which is quite cool. I've done that a few times. Locust is Python. Bees with machine guns is quite cool as well. Cool name, Bees with machine guns, like that. Security testing, yeah, my current bugbear, I love security testing at the moment. So has everyone heard of OWASP in the audience? So who has heard of OWASP? Oh, good crowd, yeah. So sadly, not many conferences I go to, people have heard of OWASP, or not that many, but definitely worth checking out. OWASP Dependency Check is a great tool. We use it it's language agnostic, there's many different versions of it in the Java space, and it basically checks for libraries you're pulling in and transitive dependencies, whether there is known CVEs, known critical vulnerabilities and exploits. Good stuff, mandatory, table stakes for us these days, table stakes. BDD security is a wrapper around OWASP Z attack proxy, so you can automate some basic penetration testing, kind of funky as well, check that out. Also recommend, threat modeling is good so far. Also recommend Docker Bench for security. If you're building on Docker Hub, pay them a bit of extra money and they'll do static scanning on your images. Because this will only capture your language dependencies, but you're building an OS in a container. Very easy to bring in something that's broken in the container. So Docker Bench, CoreOS Claire is an open source container scanner. I found it's an awesome one. It's built into Key or Quay, however you want to pronounce it, the CoreOS version of Docker Hub. So if you pay them, you can get that. You can run it individually. It's been a pain up until I did this talk a couple of weeks ago at Skills Matter. A very kind gent, I've forgotten his name, I must quote him, has actually put together a Docker container to automate all the setup of Claire, and it's super awesome. So I'm going to be using that in future now. So you can run, I was going to say don't run Claire yourself, but now you can run Claire yourself, and you should run Claire yourself. Or at least something here to scan the images you're building to make sure no heartbleed slips into production, that kind of stuff. Final article, very interesting gent called Aaron Gratifiore, works for the CIS, I think it is, and he's written a bunch of interesting stuff online, bunch of interesting talks at previous DockerCons, basically a 101 up to advanced level on container security. Talks about all the mainstream container tech, everything from defense in depth, core fundamentals, principle of least privilege, that kind of stuff, right down to AppArmor, SecOmp, syscalls. Above my head some of that stuff, but it's a really great, Aaron Gratifiore stuff, worth a Google, worth a read if you really want to get into container tech. So I work with a lot of companies who are Agile, love that, love the whole Agile thing. I see Alan in the back there, Agile on the beach, good stuff. But a lot of them push back, and when I start talking about non-functional requirements or system quality attributes, they say, no, we're Agile, we defer all this stuff to the last responsible moment. And I like the last responsible moment. I like the principle of it, yeah? I don't know much at the start. I do lots of learning. I make a decision there because I know more stuff. And I make it just before it's irresponsible. I've got the most knowledge, but if I don't make the decision, it will be made for me or it's an irresponsible decision. This is awesome for building functionality, yeah? Newsflash, not so awesome. Sometimes the last responsible moment is up front. Yeah, with security and architecture. I've worked on a few systems where some of the decisions needed to be made up front, and the fact they weren't hampered the project completely. Yeah, so modern architectures don't necessarily make this easier. I've had some microservice projects I've worked on where we had to retrofit security, and it was like 20 services, 3 different languages. Absolute nightmare, yeah? So these things, sometimes the last responsible moment, particularly with NFRs, is up front. And if you don't, it kind of leads to this thing, yeah? You can fix it right or you can fix it fast. And more often than not, you start fixing it fast, and then it's broken windows all the way, yeah? So please do take care of that one. So I'm coming dangerously close to my end of time now, but I just want to mention mechanical sympathy. This is a Java-specific thing, but if you're working with Java, bonus. If you're not, maybe have a think. Some of the older tech is not happy with things like C groups and namespaces. So in particular, Java just had JDK 9 released, but everything before JDK 9 is not C group aware. It can be constrained by the Linux system, but it thinks it's got access to more than it has. So you can, if you put a container on a box with 32 cores, when the JVM starts up, it thinks it's got 32 cores. Even if you're constraining it via C groups, it can never access more than you give it, but it bases things like garbage collection, fork join pool, a bunch of other interesting stuff based on how many processors it thinks it's got access to. 20 years ago when Java was created, it made total sense. Java got the box, Java has all the box, yeah? Not so much now with containers. So think about those things. JDK 9 has fixed this. It's not going to be backported, or it may be backported, so one to watch, yeah? Things like setting memory appropriately, always allow a bit of overhead. I see people setting their language runtimes super tight to container runtime memory, and you always need extra memory for native threads and things like that, so be careful with that. Last one, busted me a few times, my team and I. The team did great work to figure it out. Entropy, so entropy used for randomness, which is used for security operations, which is used for crypto. On a box, you're running lots of containers, particularly up in the cloud where there's not much access to entropy. There's no one moving a mouse, there's no one banging the keys or whatever. You can very quickly exhaust entropy on the box. And then when you try to do security operations, by default, a lot of the language runtimes, including Java, will block because they access entropy from dev random. And dev random is blocking when there is no entropy. So you can use dev urandom, random instead. There may be some implications on that, depending on who you believe, whether it's sort of a bit more pseudo-random or whatever. But just be aware, I've had a couple of things where I've been running in containers, it just blocks. And then when I look at the stack trace, it always blocks on crypto. And I'm like, damn it, it's the entropy thing. So just one to watch, yeah. Deployment, shameless plug for Amazon's got some cool stuff. I did a talk about service meshes, which you might find interesting later on, so you can go and check those out. Apologies for running through. 30 minutes is a bit tight with this talk. Observability, don't want to underline, this is super important, observability. People like Charity Majors, she spun up a whole company, Honeycomb.io, around stuff she did at Facebook with Scuba. So Charity's got a lot of interesting stuff. Copy Construct on Twitter is talking about this quite a lot. But observability is a key part to closing the loop of the pipeline. Yeah, key part. Finally, containers, definitely not a silver bullet. Hopefully this kind of audience kind of gets that. When migrating to containers, the vendors might be selling you this. I think go for this, personally, yeah. I know that's often used as a derogatory image for Docker, but I like this. Start small, get big, yeah. Let Matthew take a picture of that one. I often get asked this, should I, this Kubernetes, this looks complicated. Should I build my own container platform? Probably not. Unless you're Google, Amazon, or Microsoft, IBM, take your pick, yeah. But whatever you do, there's probably some glue components you need to do. Build a pipeline around that. Everything is code. Everything has its pipeline. Keith's book, awesome book. Not going to make you a Terraform or Ansible expert, but it will set you up with the ideas of infrastructure of code. Real nice book. And finally, I can then slow down a little bit. Using containers does not obviate the need for good architectural practices, and I'll also say there, and good common sense, yeah? Otherwise, you get this kind of thing. We crammed this monolith into a container and called it a microservice, yeah? Which is, this is Casey West, the hat tip to Casey on this stuff. I have seen this kind of stuff a little bit. So that's pretty much it. Apologies, slightly fast because the talk was generally longer. There's a few online videos where I'm speaking a bit slower as well, so you can watch them to your leisure. But continuous delivery, vitally important, particularly with modern architectures, modern platforms. Container image now is your single source of truth. Don't repackage stuff down the pipeline. Add metadata. Think about your software supply chain. Think about your provenance, your governance. Understand the fabric, mechanical sympathy, whatever you're deploying onto, cloud, containers. Super important. Not all developers are aware of this stuff, and what you should do is educate them and then assert the properties in the build pipeline. Finally, the tooling is now becoming mature and stable. When I started working in this space, particularly a big project with Not on the High Street, I'll shout them out, about 3 years ago, we had to bake a lot of our own stuff. And now there's lots of tools out there. We really just need to reapply existing principles and practices of continuous delivery. Hat tip again to Jez and Dave. Apply this kind of stuff to the new technologies. Yeah. More bedtime reading for you, because I haven't given you enough information yet. So on that note, I should say thanks a lot.